Start recording. My name is Edel Kiprop, and today I will be demonstrating my 4-bit counter circuit. It comes in hexadecimal from 0 to F based on the control inputs. So this is my complete circuit, and it has the following inputs: U, which is a toggle switch. When off, it is set to 0. When it is on, it is set to high. This is my reset switch. It has a clock which is set to 1 hertz and increments on or decrements the counter by 1 depending on what input you would have switched on for you. And then we have a constant, and then we have flip-flops that store the current state for the counter and holds values between clock pulses. I have 4 components, custom components for my flip-flop. That is D0, which is the least significant bit, and I also have D3, the most significant bit. I also have D2 and D1, D2 and D1. And let's test this. So when we click on clock, our constant, and then reset, so all our inputs are switched on. So we will test. I will demonstrate when we set U to high, that is, we switch on our switch, and you will see the counter will count from F going up. So I'll switch on my reset, and it will count going up. After F, it will wrap back to 0 and continue in a loop until I click on my reset button, this, and it will reset the counter back to F. So once after F, it will wrap up back to 0 and continue in a loop, counting going up until I click on my reset, and my display would show F. So when I set my input U to 0, that is low, and click on reset, my display will start, my counter will count from F going down, and after 0 it will wrap up to F and continue in a loop until I reset my counter. So it will continue in a loop, counting going down until I click my reset counter, and my display will go back to F. And this is my demonstration for my 4-bit counter.